So my name is Kennie Merz. I'm the director of the Institute of Cyber-Enabled Research, and which also subsumes High Performance Computing Center. I'm absolutely ecstatic. I don't know how to really put it, to be standing here in front of you today. This really represents about 2 years of just trial and tribulation to put this together and planning in terms of setting up this computer. But it's not also about me. It's not about my excitement. It's about the excitement for MSU and the community here. We're bringing today a state-of-the-art machine that's going to allow researchers on campus to really tackle fundamentally different and interesting problems using computation. Today, sorry, I'm trying to shift between talk and kind of pre-thought things. So. Basically, the machine will probably double the performance of the current equipment we have. It'll be much, much faster to do the calculations. And I think also what's really exciting about this is that we can now attract and retain top-flight faculty that are interested in the computational sciences. Moreover, it's going to allow us to generate partnerships and relationships with other universities and potentially companies in town. Also, through this kind of computational resource, new methodologies and new technologies are discovered, and this will allow us to spin out potentially small companies, startup companies to do, create new businesses and benefit both the Lansing and Michigan economies. So, when I was sort of preparing this this talk over the last few months, you're reading various quotes in various places. And I thought, well, now that the NBA season's almost over, I think we have a few more games before we need to decide that, and the NHL season's over, we start thinking about the boys of summer. And this baseball quote came across my desk. And this is a quote from Joe DiMaggio about opening day. So this is an opening day, and we're all excited about this new machine and what it can do for us. And we get a kick. It's like, birthday party, a new toy when you're a kid. But I think this quote also is really important in terms of some of the depth behind it. On opening day, of course, everyone's going to win the World Series, right? Everyone's going to be the MVP of the league. But it's really what's important is the season. And so I think even in this quote, he's sort of presaging the fact that what's really important is how this machine is going to be used in the coming months and years. The lifetime of this type of machine is in the order of 3 to 5 years. And so what do people use this for in the next handful of months is really going to be what's important. So with that in mind, what can we do with this kind of equipment? There's a number of kinds of problems you can tackle with this. And my particular research area is computer-aided drug design, virtual screening type technologies that use high-performance computing. Michigan State has quite a tradition in drug discovery. Cisplatin was discovered here at Michigan State a number of years ago. This still remains one of the most important frontline anti-cancer drugs. You can use modern supercomputers like this to actually design drugs from first principles. You take structures developed from X-ray crystallography experiments, and you can dock small molecules into the pocket and actually study their interactions. There's many companies across the country now, including a little startup I founded, that use computer-based technologies to design drugs from first principles. Other things you can do is you can understand our place in the cosmos. You can understand weather. You can understand movement of people, populations, using these kinds of computers. So we can better understand the world around us and the interactions with our environment. Michigan State is famous, of course, for its crop sciences, and this slide is just representing the fact that many people using this machine, both at Michigan State and around the world, use genetic type strategies to look at food crops and try to optimize their yield or improve their ability to handle very arid or dry environments. And this is another kind of application area that you can be involved in. This last one is an attempt to represent nanostructure and molecular sort of design. It's a DNA double helix. There's many sort of advanced manufacturing kinds of studies that are going on both here at Michigan State, where you can use the computer to go ahead and understand how to assemble the molecules and then actually synthesize these in the lab. So this gives you a kind of a sense of the things we can do with these kinds of resources now that we have at Michigan State University. So if we will, let's go ahead and welcome our new addition, which we've called LACONIA. And for those of you who are maybe not familiar with Greek history or Greek geography, this is the Peloponnesus Peninsula, which is now an island actually because of the Corinth Canal. But LACONIA was the home region of Sparta, which was the home of the Spartans. So we thought this was a quite appropriate name for this particular machine. I've had the ability to tour this area. It's a very, very beautiful area. It's typically rated one of the most beautiful areas in Europe to tour around. The coast is gorgeous, and the various valleys in this region are quite spectacular. So let me now tell you a little bit about our latest machine. So again, it's called LACONIA, and it comprises 322 compute nodes. Each node has 28 CPUs and 128 gigabytes of memory. Now, to give you a sense of scale on this, when I was a graduate student in 1985, I had the chance to have access to the so-called Cray computer. This is a $10, $15 million machine, and I compiled my code and got it going. It was 500 times faster. I thought, man, this is just amazing, right? One blade of this machine, one 28 process CPU blade, is about 1 million times faster than that machine of 30 years ago. So it's just a tremendous increase in compute power. And again, the price of this blade is on the order of $5,000. So the price-performance ratio is really spectacular. The other thing that we have in this is we have so-called graphical processing units. So many of you maybe like playing video games, maybe not so much in this audience, but many of us have children that sometimes we like them to get away from the console. And but the graphical processing units, again, were originally used for game players, but it was discovered that these could actually carry out very high performance calculations. So our machine also contains 50 blades that have 4 GPUs each, the top-of-the-line blades from NVIDIA. And again, this brings great, tremendous power to the machine. The total machine delivers over 500 megaflops, teraflops, I'm back in the 80s. So 0.5 petaflop overall of computer performance. This is going to place us roughly, we believe, in the top 200, but we'll know next week, of the top supercomputers in the world. And most importantly, it's going to place us in the top 50 or so of the green computers of the world, and we'll find out about where we'll actually rank in the coming months. So it's really quite exciting machine overall in terms of its overall performance. So this is the top 500 list if you're interested in. So a machine like this doesn't exist in a vacuum, right? Michigan State, to the great credit, has really committed to this, and I'm just going to talk a little bit briefly about some of the buy-in users. These are the people that have actually provided sort of accounts. There's many, many other people that have bought in. We've basically have sold over half the machine to folks on campus, and that really shows how important it is to have a resource like this and what kind of demand there is. And I was just told by Sharon that the machine's already 90% utilized. And so again, it's just been taken over immediately by researchers on campus. So this is just a brief list. There's many others that should be on this list. But importantly, there's been a number of people over the years that have contributed to this effort. The Vice President's Office, headed by Stephen Chu now, has contributed to this, to ICER, and the purchase of the machine. June Uat has contributed to this. Joanna Young's department, the Chief Technology Officer. EFRIB, Thomas Glasmacher, I don't know if Thomas is here, his group has contributed to it. Leo, I see sitting in the corner, staring me down. He's the Dean of the College of Engineering. He's contributed to this over the years, his college. Jim Kirkpatrick, College of Natural Sciences, and finally the Interim Dean of Social Sciences has contributed to this effort as well. The other thing is we were really blessed with a wonderful team to work with. I really want to shout out to Lenovo. They've really worked just beautifully with us, setting up this machine. They've delivered everything on time to pretty much the spec. I just can't imagine it going much smoother than it had. Also Mellanox, the other partners, they provide the high performance interconnect that this machine has. NVIDIA, some of the NVIDIA folks here, and excuse me, Intel's provided essentially the chips.